Jules Henri Poincaré. Copyright was a French mathematician, theoretical physicist, engineer, and a philosopher of science. He is often described as a polymath, and in mathematics as the last universalist by Eric Temple Bell, since he excelled in all fields of the discipline as it existed during his lifetime. As a mathematician and physicist, he made many original fundamental contributions to pure and applied mathematics, mathematical physics, and celestial mechanics. He was responsible for formulating the Poincaré copyright conjecture, which was one of the most famous unsolved problems in mathematics until it was solved in 2002–2003. In his research on the three-body problem, Poincaré copyright became the first person to discover a chaotic deterministic system which laid the foundations of modern chaos theory. He is also considered to be one of the founders of the field of topology. Poincaré copyright made clear the importance of paying attention to the invariance of laws of physics under different transformations, and was the first to present the Lorentz transformations in their modern symmetrical form. Poincaré copyright discovered the remaining relativistic velocity transformations and recorded them in a letter to Dutch physicist Hendrik Lorentz in 1905. Thus he obtained perfect invariance of all of Maxwell's equations, an important step in the formulation of the theory of special relativity. The Poincaré copyright group used in physics and mathematics was named after him. Life: Poincaré copyright was born on April 29, 1854 in Cité Copyright Duquesne neighborhood, Nancy, Meurthe-et-Moselle into an influential family. His father Léon Poincaré copyright was a professor of medicine at the University of Nancy. His adored younger sister Aileen married the spiritual philosopher Émile Boutroux. Another notable member of Henri's family was his cousin, Raymond Poincaré copyright, who would become the President of France, 1913–1920, and a fellow member of the Académie copyright My Frère Sectionnaires. He was raised in the Roman Catholic faith. However, he later on became an agnostic and criticized religious dogmas, particularly with respect to the mixing of theology and science. Education: during his childhood he was seriously ill for a time with diphtheria and received special instruction from his mother, Hugues copyright Nai Launoy. In 1862, Henri entered the L'École copyright in Nancy. He spent 11 years at the L'École copyright and during this time he proved to be one of the top students in every topic he studied. He excelled in written composition. His mathematics teacher described him as a monster of mathematics, and he won first prizes in the concours Gar copyright Na copyright RAL, a competition between the top pupils from all the L'École copywriters across France. His poorest subjects were music and physical education, where he was described as average at best. However, poor eyesight and a tendency towards absent-mindedness may explain these difficulties. He graduated from the L'École copyright in 1871 with a bachelor's degree in letters and sciences. During the Franco-Prussian War of 1870, he served alongside his father in the ambulance corps. Poincaré copyright entered the École Polytechnique in 1873 and graduated in 1875. There he studied mathematics as a student of Charles Hermite, continuing to excel and publishing his first paper in 1874. From November 1875 to June 1878 he studied at the École des Mines, while continuing the study of mathematics in addition to the mining engineering syllabus, and received the degree of ordinary mining engineer in March 1879. As a graduate of the École des Mines, he joined the Corps des Mines as an inspector for the Vassal region in northeast France. He was on the scene of a mining disaster at Megny in August 1879 in which 18 miners died. He carried out the official investigation into the accident in a characteristically thorough and humane way. At the same time, Poincaré copyright was preparing for his doctorate in sciences in mathematics under the supervision of Charles Hermite. His doctoral thesis was in the field of differential equations. It was named Sur les propriétés copyright tar copyright des fonctions dar copyright finis par les copyright quotients differ copyright parentheses. Poincaré copyright devised a new way of studying the properties of these equations. He not only faced the question of determining the integral of such equations, but also was the first person to study their general geometric properties. He realized that they could be used to model the behavior of multiple bodies in free motion within the solar system. Poincaré copyright graduated from the University of Paris in 1879. The first scientific achievements. After receiving his degree, Poincaré copyright began teaching as junior lecturer in mathematics at the University of Caen in Normandy. At the same time he published his first major article concerning the treatment of a class of automorphic functions. There, in Caen, he met his future wife, Louise Poulin d'Andézy, and on April 20, 1881, they married. Together they had 4 children, Jeanne, Yvonne, Henriette, and La. Copyright on. Poincaré copyright immediately established himself among the greatest mathematicians of Europe, attracting the attention of many prominent mathematicians. In 1881 Poincaré copyright was invited to take a teaching position at the Faculty of Sciences of the University of Paris. He accepted the invitation. During the years of 1883 to 1897, he taught mathematical analysis in a Permel-Cole Polytechnique. In 1881–1882, Poincaré copyright created a new branch of mathematics, the qualitative theory of differential equations. He showed how it is possible to derive the most important information about the behavior of a family of solutions without having to solve the equation. He successfully used this approach to problems in celestial mechanics and mathematical physics. Career: he never fully abandoned his mining career to mathematics. He worked at the Ministry of Public Services as an engineer in charge of Northern Railway development from 1881 to 1885. He eventually became chief engineer of the Corps des Mines in 1893 and inspector general in 1910. Beginning in 1881 and for the rest of his career, he taught at the University of Paris. He was initially appointed as the more registered trademark to de Confar copyright Renses d'Analyse. Eventually, he held the chairs of physical and experimental mechanics, mathematical physics and theory of probability, and celestial mechanics and astronomy. In 1887, at the young age of 32, Poincaré copyright was elected to the French Academy of Sciences. He became its president in 1906, and was elected to the Académie copyright my sectionnaires in 1909. In 1887, he won Oscar II, King of Sweden's mathematical competition for a resolution of the three-body problem concerning the free motion of multiple orbiting bodies. In 1893, Poincaré copyright joined the French Bureau des Longitudes, which engaged him in the synchronization of time around the world. In 1897 Poincaré copyright backed an unsuccessful proposal for the decimalization of circular measure, and hence time and longitude. It was this post which led him to consider the question of establishing international time zones and the synchronization of time between bodies in relative motion. In 1899, and again more successfully in 1904, he intervened in the trials of Alfred Dreyfus. He attacked the spurious scientific claims of some of the evidence brought against Dreyfus, who was a Jewish officer in the French army charged with treason by colleagues. In 1912, Poincaré copyright underwent surgery for a prostate problem and subsequently died from an embolism on July 17, 1912, in Paris. He was 58 years of age. He is buried in the Poincaré copyright family vault in the cemetery of Montparnasse, Paris. A former French Minister of Education, Claude Allegri, has recently proposed that Poincaré copyright be reburied in the Panther copyright on in Paris, which is reserved for French citizens only of the highest honor. Students: Poincaré copyright had 2 notable doctoral students at the University of Paris, Louis Baclier and Dimitri Pompou. Work summary: Poincaré copyright made many contributions to different fields of pure and applied mathematics such as celestial mechanics, fluid mechanics, optics, electricity, telegraphy, capillarity, elasticity, thermodynamics, potential theory, quantum theory, theory of relativity and physical cosmology. He was also a popularizer of mathematics and physics and wrote several books for the lay public. Among the specific topics he contributed to are the following: algebraic topology, the theory of analytic functions of several complex variables, the theory of abelian functions, algebraic geometry. Poincaré copyright was responsible for formulating one of the most famous problems in mathematics, the Poincaré copyright conjecture, proven in 2003 by Grigory Perelman. Poincaré copyright recurrence theorem, hyperbolic geometry, number theory, the three-body problem, the theory of Diophantine equations, the theory of electromagnetism, the special theory of relativity. In an 1894 paper, he introduced the concept of the fundamental group. In the field of differential equations, Poincaré copyright has given many results that are critical for the qualitative theory of differential equations, for example the Poincaré copyright sphere and the Poincaré copyright map. Poincaré copyright on everybody's belief in the normal law of errors, published an influential paper providing a novel mathematical argument in support of quantum mechanics. The three-body problem, the problem of finding the general solution to the motion of more than two orbiting bodies in the Solar System had eluded mathematicians since Newton's time. This was known originally as the three-body problem and later the n-body problem, where n is any number of more than two orbiting bodies. The n-body solution was considered very important and challenging at the close of the 19th century. Indeed, in 1887, in honor of his 60th birthday, Oscar II, King of Sweden, advised by paragraph star Mittagalaffala, established a prize for anyone who could find the solution to the problem. The announcement was quite specific: in case the problem could not be solved, any other important contribution to classical mechanics would then be considered to be prizeworthy. The prize was finally awarded to Poincaré copyright, even though he did not solve the original problem. One of the judges, the distinguished Carl Weierstrass, said, "This work cannot indeed be considered as furnishing the complete solution of the question proposed, but that it is nevertheless of such importance that its publication will inaugurate a new era in the history of celestial mechanics." The version finally printed contained many important ideas which led to the theory of chaos. The problem as stated originally was finally solved by Carl F. Sundman for now equals A3 in 1912 and was generalized to the case of now A3 bodies by Qudong Wang in the 1990s. Work on relativity. Local time. Poincaré copyright's work at the Bureau des Longitudes on establishing international time zones led him to consider how clocks at rest on the Earth, which would be moving at different speeds relative to absolute space, could be synchronized. At the same time, Dutch theorist Hendrik Lorentz was developing Maxwell's theory into a theory of the motion of charged particles, and their interaction with radiation. In 1895 Lorentz had introduced an auxiliary quantity called local time and introduced the hypothesis of length contraction to explain the failure of optical and electrical experiments to detect motion relative to the ether. Poincaré copyright was a constant interpreter of Lorentz's theory. Poincaré copyright as a philosopher was interested in the deeper meaning. Thus he interpreted Lorentz's theory and in so doing he came up with many insights that are now associated with special relativity. In The Measure of Time, Poincaré copyright said, "A little reflection is sufficient to understand that all these affirmations have by themselves no meaning. They can have one only as the result of a convention." He also argued that scientists have to set the constancy of the speed of light as a postulate to give physical theories the simplest form. Based on these assumptions he discussed in 1900 Lorentz's wonderful invention of local time and remarked that it arose when moving clocks are synchronized by exchanging light signals assumed to travel with the same speed in both directions in a moving frame. Principle of relativity and Lorentz transformations. He discussed the principle of relative motion in two papers in 1900 and named it the principle of relativity in 1904, according to which no physical experiment can discriminate between a state of uniform motion and a state of rest. In 1905 Poincaré copyright wrote to Lorentz about Lorentz's paper of 1904, which Poincaré copyright described as a paper of supreme importance. In this letter he pointed out an error Lorentz had made when he had applied his transformation to one of Maxwell's equations, that for charge-occupied space, and also questioned the time dilation factor given by Lorentz. In a second letter to Lorentz, Poincaré copyright gave his own reason why Lorentz's time dilation factor was indeed correct after all. it was necessary to make the Lorentz transformation form a group and gave what is now known as the relativistic velocity addition law. Poincaré copyright later delivered a paper at the meeting of the Academy of Sciences in Paris on June 5, 1905 in which these issues were addressed. In the published version of that he wrote, and showed that the arbitrary function must be unity for all to make the transformations form a group. In an enlarged version of the paper that appeared in 1906, Poincaré copyright pointed out that the combination is invariant. He noted that a Lorentz transformation is merely a rotation in four-dimensional space about the origin by introducing as a fourth imaginary coordinate, and he used an early form of four vectors. Poincaré copyright expressed a disinterest in a four-dimensional reformulation of his new mechanics in 1907, because in his opinion the translation of physics into the language of four-dimensional geometry would entail too much effort for limited profit. So it was Hermann Minkowski who worked out the consequences of this notion in 1907. Mass-energy relation, like others before, Poincaré copyright discovered a relation between mass and electromagnetic energy. While studying the conflict between the action-reaction principle and Lorentz ether theory, he tried to determine whether the center of gravity still moves with a uniform velocity when electromagnetic fields are included. He noticed that the action-reaction principle does not hold for matter alone, but that the electromagnetic field has its own momentum. Poincaré copyright concluded that the electromagnetic field energy of an electromagnetic wave behaves like a fictitious fluid with a mass density of EC2. If the center of mass frame is defined by both the mass of matter and the mass of the fictitious fluid, and if the fictitious fluid is indestructible it's neither created or destroyed then the motion of the center of mass frame remains uniform. But electromagnetic energy can be converted into other forms of energy. So Poincaré copyright assumed that there exists a non-electric energy fluid at each point of space, into which electromagnetic energy can be transformed and which also carries a mass proportional to the energy. In this way, the motion of the center of mass remains uniform. Poincaré copyright said that one should not be too surprised by these assumptions, since they are only mathematical fictions. However, Poincaré copyright's resolution led to a paradox when changing frames. If a Hertzian oscillator radiates in a certain direction, it will suffer a recoil from the inertia of the fictitious fluid. Poincaré copyright performed a Lorentz boost to the frame of the moving source. He noted that energy conservation holds in both frames, but that the law of conservation of momentum is violated. This would allow perpetual motion, a notion which he abhorred. The laws of nature would have to be different in the frames of reference, and the relativity principle would not hold. Therefore he argued that also in this case there has to be another compensating mechanism in the ether. Poincaré copyright himself came back to this topic in his St. Louis lecture. This time he rejected the possibility that energy carries mass and criticized the ether solution to compensate the above-mentioned problems. The apparatus will recoil as if it were a cannon and the projected energy a ball, and that contradicts the principle of Newton, since our present projectile has no mass. It is not matter, it is energy. Shall we say that the space which separates the oscillator from the receiver and which the disturbance must traverse in passing from one to the other, is not empty, but is filled not only with ether, but with air, or even an interplanetary space with some subtle, yet ponderable fluid? That this matter receives the shock, as does the receiver, at the moment the energy reaches it, and recoils, when the disturbance leaves it? That would save Newton's principle, but it is not true. If the energy during its propagation remained always attached to some material substratum, this matter would carry the light along with it, and Fizeau has shown, at least for the air, that there is nothing of the kind. Michelson and Morley have since confirmed this. We might also suppose that the motions of matter proper were exactly compensated by those of the ether. But that would lead us to the same considerations as those made a moment ago. The principle, if thus interpreted, could explain anything, since whatever the visible motions we could imagine hypothetical motions to compensate them. But if it can explain anything, it will allow us to foretell nothing. It will not allow us to choose between the various possible hypotheses, since it explains everything in advance. it therefore becomes useless. He also discussed two other unexplained effects: non-conservation of mass implied by Lorenz's variable mass, Abraham's theory of variable mass, and Kaufmann's experiments on the mass of fast-moving electrons, and the non-conservation of energy in the radium experiments of Madame Curie. It was Albert Einstein's concept of mass-energy equivalence that a body losing energy as radiation or heat was losing mass of amount μ equals EC2 that resolved Poincaré copyright's paradox, without using any compensating mechanism within the ether. The Hertzian oscillator loses mass in the emission process, and momentum is conserved in any frame. However, concerning Poincaré copyright's solution of the center of gravity problem, Einstein noted that Poincaré copyright's formulation and his own from 1906 were mathematically equivalent. Poincaré copyright and Einstein's first paper on relativity was published 3 months after Poincaré copyright's short paper, but before Poincaré copyright's longer version. Einstein relied on the principle of relativity to derive the Lorentz transformations and used a similar clock synchronization procedure to the one that Poincaré copyright had described, but Einstein's was remarkable in that it contained no references at all. Poincaré copyright never acknowledged Einstein's work on special relativity. Einstein acknowledged Poincaré copyright posthumously in the text of a lecture in 1921 called Geometry Undefined in connection with non-Euclidean geometry, but not in connection with special relativity. A few years before his death, Einstein commented on Poincaré copyright as being one of the pioneers of relativity, saying Lorentz had already recognized that the transformation named after him is essential for the analysis of Maxwell's equations, and Poincaré copyright deepened this insight still further. Algebra and number theory. Poincaré copyright introduced group theory to physics, and was the first to study the group of Lorentz transformations. He also made major contributions to the theory of discrete groups and their representations. Topology. The subject is clearly defined by Felix Klein in his Erlangen program: the geometry invariance of arbitrary continuous transformation, a kind of geometry. The term topology was introduced, as suggested by Johann Benedict Listing, instead of previously used analysis situs. Some important concepts were introduced by Enrico Betti and Bernhard Riemann. But the foundation of this science, for a space of any dimension, was created by Poincaré copyright. His first article on this topic appeared in 1894. His research in geometry led to the abstract topological definition of homotopy and homology. He also first introduced the basic concepts and invariants of combinatorial topology, such as Betti numbers and the fundamental group. Poincaré copyright proved a formula relating the number of edges, vertices and faces of n-dimensional polyhedron and gave the first precise formulation of the intuitive notion of dimension. Astronomy and celestial mechanics. Poincaré copyright published 2 now classical monographs, New Methods of Celestial Mechanics, and Lectures on Celestial Mechanics. In them, he successfully applied the results of their research to the problem of the motion of 3 bodies and studied in detail the behavior of solutions. They introduced the small parameter method, fixed points, integral invariance, variational equations, the convergence of the asymptotic expansions. Generalizing a theory of Brunn's, Poincaré copyright showed that the 3-body problem is not integrable. In other words, the general solution of the 3-body problem cannot be expressed in terms of algebraic and transcendental functions through unambiguous coordinates and velocities of the bodies. His work in this area were the first major achievements in celestial mechanics since Isaac Newton. These include the idea of Poincaré copyright, who later became the base for mathematical chaos theory, and the general theory of dynamical systems. Poincaré copyright authored important works on astronomy for the equilibrium figures gravitating-rotating fluid. He introduced the important concept of bifurcation points, proved the existence of equilibrium figures of non-ellipsoid, including ring-shaped and pear-shaped figures, their stability. For this discovery, Poincaré copyright received the Gold Medal of the Royal Astronomical Society. Differential equations and mathematical physics. After defending his doctoral thesis on the study of singular points of the system of differential equations, Poincaré copyright wrote a series of memoirs under the title On Curves Defined by Differential Equations. In these articles, he built a new branch of mathematics, called qualitative theory of differential equations. Poincaré copyright showed that even if the differential equation cannot be solved in terms of known functions, yet from the very form of the equation, a wealth of information about the properties and behavior of the solutions can be found. In particular, Poincaré copyright investigated the nature of the trajectories of the integral curves in the plane, gave a classification of singular points, introduced the concept of a limit cycle and the loop index, and showed that the number of limit cycles is always finite, except for some special cases. Poincaré copyright also developed a general theory of integral invariance and solutions of the variational equations. For the finite difference equations, he created a new direction the asymptotic analysis of the solutions. He applied all these achievements to study practical problems of mathematical physics and celestial mechanics, and the methods used were the basis of its topological works. The singular points of the integral curves. Assessments. Poincaré copyright's work in the development of special relativity is well recognized, though most historians stress that despite many similarities with Einstein's work, the two had very different research agendas and interpretations of the work. Poincaré copyright developed a similar physical interpretation of local time and noticed the connection to signal velocity, but contrary to Einstein he continued to use the ether concept in his papers and argued that clocks in the ether show the true time, and moving clocks show the local time. So Poincaré copyright tried to keep the relativity principle in accordance with classical concepts, while Einstein developed a mathematically equivalent kinematics based on the new physical concepts of the relativity of space and time. While this is the view of most historians, a minority go much further, such as E.T. Whittaker, who held that Poincaré copyright and Lorentz were the true discoverers of relativity. Character. Poincaré copyright's work habits have been compared to a bee flying from flower to flower. Poincaré copyright was interested in the way his mind worked. He studied his habits and gave a talk about his observations in 1908 at the Institute of General Psychology in Paris. He linked his way of thinking to how he made several discoveries. The mathematician Dubut claimed he was unintuitive, arguing that this is demonstrated by the fact that he worked so often by visual representation. He did not care about being rigorous and disliked logic. Toulouse's characterization, Poincaré copyright's mental organization was not only interesting to Poincaré copyright himself but also to Émile de Toulouse, a psychologist of the psychology laboratory of the School of Higher Studies in Paris. Toulouse wrote a book entitled Henri Poincaré Copyright. In it, he discussed Poincaré copyright's regular schedule. He worked during the same times each day in short periods of time. He undertook mathematical research for 4 hours a day, between 10 a.m. and noon, then again from 5 p.m. to 7 p.m. he would read articles in journals later in the evening. His normal work habit was to solve a problem completely in his head, then commit the completed problem to paper. He was ambidextrous and nearsighted. His ability to visualize what he heard proved particularly useful when he attended lectures, since his eyesight was so poor that he could not see properly what the lecturer wrote on the blackboard. These abilities were offset to some extent by his shortcomings. He was physically clumsy and artistically inept. He was always in a rush and disliked going back for changes or corrections. He never spent a long time on a problem since he believed that the subconscious would continue working on the problem while he consciously worked on another problem. In addition, Toulouse stated that most mathematicians worked from principles already established while Poincaré copyright started from basic principles each time. His method of thinking is well summarized as Habitua copyright in our copyright gliga laidar copyright tales et ni regarder que les seems, il percep de l'un l'autre avec une promptitude subnantier les faits qu'il dar copyright covrait se groupant deux marmes autour de la centre copyright et instantané copyright mente automatiquement classe copyright est dans arma copyright moi. Attitude towards transfinite numbers. Poincaré copyright was dismayed by Georg Cantor's theory of transfinite numbers, and referred to it as a disease from which mathematics would eventually be cured. Poincaré copyright said, "There is no actual infinite." The Cantorians have forgotten this, and that is why they have fallen into contradiction. Honors, awards, Oscar II, King of Sweden's mathematical competition, American Philosophical Society 1899 Gold Medal of the Royal Astronomical Society of London, Bolyai Prize in 1905, Matteucci Medal 1905, French Academy of Sciences 1906, Acadé Copyright My Sectionnaires 1909, Bruce Medal, named after him, Institut Henri Poincaré Copyright, Poincaré Copyright Prize, Annals Henri Poincaré Copyright, Poincaré Copyright Seminar, The Crater Poincaré Copyright on the Moon, Asteroid 2021 Poincaré Copyright, Philosophy. Poincaré copyright had philosophical views opposite to those of Bertrand Russell and Gottlob Frege, who believed that mathematics was a branch of logic. Poincaré copyright strongly disagreed, claiming that intuition was the life of mathematics. Poincaré copyright gives an interesting point of view in his book Science and Hypothesis. For a superficial observer, scientific truth is beyond the possibility of doubt. The logic of science is infallible, and if the scientists are sometimes mistaken, this is only from their mistaking its rule. Poincaré copyright believed that arithmetic is a synthetic science. He argued that Peano's axioms cannot be proven non-circularly with the principle of induction, therefore concluding that arithmetic is a priori synthetic and not analytic. Poincaré copyright then went on to say that mathematics cannot be deduced from logic since it is not analytic. His views were similar to those of Immanuel Kant. He strongly opposed Cantorian set theory, objecting to its use of impredicative definitions. However, Poincaré copyright did not share Kantian views in all branches of philosophy and mathematics. For example, in geometry, Poincaré copyright believed that the structure of non-Euclidean space can be known analytically. Poincaré copyright held that convention plays an important role in physics. His view came to be known as conventionalism. Poincaré copyright believed that Newton's first law was not empirical but is a conventional framework assumption for mechanics. He also believed that the geometry of physical space is conventional. He considered examples in which either the geometry of the physical fields or gradients of temperature can be changed, either describing a space as non-Euclidean measured by rigid rulers, or as a Euclidean space where the rulers are expanded or shrunk by a variable heat distribution. However, Poincaré copyright thought that we were so accustomed to Euclidean geometry that we would prefer to change the physical laws to save Euclidean geometry rather than shift to a non-Euclidean physical geometry. Free will. Poincaré copyright's famous lectures before the Société copyright de psychologie in Paris were cited by Jacques Hadamard as the source for the idea that creativity and invention consist of two mental stages, first random combinations of possible solutions to a problem, followed by a critical evaluation. Although he most often spoke of a deterministic universe, Poincaré copyright said that the subconscious generation of new possibilities involves chance. It is certain that the combinations which present themselves to the mind in a kind of sudden illumination after a somewhat prolonged period of unconscious work are generally useful and fruitful combinations. All the combinations are formed as a result of the automatic action of the subliminal ego, but those only which are interesting find their way into the field of consciousness. A few only are harmonious, and consequently at once useful and beautiful, and they will be capable of affecting the geometrician's special sensibility I have been speaking of, which, once aroused, will direct our attention upon them, and will thus give them the opportunity of becoming conscious. In the subliminal ego, on the contrary, there reigns what I would call liberty, if one could give this name to the mere absence of discipline and to disorder born of chance. Poincaré copyright two stages random combinations followed by selection became the basis for Daniel Dennett's two-stage model of free will. See also. References. This article incorporates material from Jules Henri Poincaré copyright on Planet Math, which is licensed under the Creative Commons Attribution Share Alike license. Footnotes and primary sources. Poincaré copyright writings in English translation, Popular Writings on the Philosophy of Science, Poincaré copyright, Henri, The Foundations of Science, New York, Science Presser. Reprinted in 1921. This book includes the English translations of Science and Hypothesis, The Value of Science, Science and Method. 1904. Science and Hypothesis, The Walter Scott Publishing, Colorado, 1913. The New Mechanics, The Monist, Vol. XXIII. 1913. The Relativity of Space, The Monist, Vol. XXIII. 1913. Last Essays, New York, Dover reprint, 1963 1956. Chance. In James A. Newman, ed., The World of Mathematics. 1958. The Value of Science, New York, Dover. On Algebraic Topology, 1895. Analysis Cytosur. The First Systematic Study of Topology. On Celestial Mechanics, 1892 €99. New Methods of Celestial Mechanics, 3 vols. English trans, 1967. ISBN 1-56396-117-2. 1905. The Capture Hypothesis of JJC, The Monist, Vol. 15. 1905 €10. Lessons of Celestial Mechanics. On the Philosophy of Mathematics, B. Weld, William B., ed., 1996. From Kuhn to Hilbert, A Source Book in the Foundations of Mathematics, 2 vols. Oxford University Press. Contains the following works by Poincaré, copyright, 1894, On the Nature of Mathematical Reasoning, 972 €81. 1898, On the Foundations of Geometry, 982 €1011. 1900, Intuition and Logic in Mathematics, 1012 €20. 1905 €06, Mathematics and Logic, €3, 1021 €70. 1910, On Transfinite Numbers, 1071 €74. 1905. The Principles of Mathematical Physics, The Monist, Vol. 15. 1910. The Future of Mathematics, The Monist, Vol. 20. 1910. Mathematical Creation, The Monist, Vol. 20. Other, 1904. Maxwell's Theory and Wireless Telegraphy, New York, McGraw Publishing Company, 1905. The New Logics, The Monist, Vol. 15. 1905. The Latest Efforts of the Logisticians, The Monist, Vol. 15. General References, Bell, Eric Temple, 1986. Men of Mathematics. Touchstone Books. ISBN 0-671-62818-6. Belliver, Andrew copyright, 1956. Henri Poincaré copyright ou la vocation souveraine. Paris, Gallimard. Bernstein, Peter L., 1996. Against the Gods, A Remarkable Story of Risk, John Wiley & Sons. Boyer, B. Carl, 1968. A History of Mathematics, Henri Poincaré copyright, John Wiley & Sons. Grattan Guinness, Ivor, 2000. The Search for Mathematical Roots 1870 -1940. Princeton Uni. Press. Dauben, Joseph, Georg Cantor, The Battle for Transfinite Set Theory, Proceedings of the 9th ACMS Conference, ppA 1 €22a. Internet version published in Journal of the ACMS 2004. Folina, Janet, 1992. Poincaré copyright and the Philosophy of Mathematics. Macmillan, New York. Gray, Jeremy, 1986. Linear Differential Equations and Group Theory from Riemann to Poincaré copyright, Birkhauser, Jean Mohan, Henri Poincaré copyright. A Life in the Service of Science, Notices of the AMS 52, 1036 €1044, Kolak, Daniel, 2001. Lovers of Wisdom, 2nd ed. Wadsworth. Muzzy, 1998. Henri Poincaré copyright. O'Connor, J. John, and Robertson, F. Edmund, 2002, Jules Henri Poincaré copyright. University of St Andrews, Scotland. Peterson, Ivars, 1995. Newton's Clock, Chaos in the Solar System W. H. Freeman and Company. ISBN 0-7167-2724-2. Sagerat, Jules, 1911. Henri Poincaré copyright. Paris, Mercure de France. Toulouse, E., 1910. Henri Poincaré copyright a Euro, source biography in French, at University of Michigan Historic Math Collection. Behalst, Ferdinand, 2012. Henri Poincaré copyright. Impatient Genius. N. Y. Springer. Secondary sources to work on relativity, Couvach, Camillo, Henri Poincaré copyright S. Mathematical Contributions to Relativity and the Poincaré copyright stresses, American Journal of Physics 36, 1102 Euro 1113, Bibcode, 1968 MJPH 36.1102C, doi, 10.1119/1.1974373. D'Arigel, O., Henri Poincaré copyright S. Criticism of fin de siècle electrodynamics, Studies in History and Philosophy of Science 26, 1 Euro 44, doi. 10.1016/1355-2198, 95, 00003 Carr, D'Arigel, O., Electrodynamics from Ampere copyright Rita Einstein, Oxford, Clarendon Press, ISBN A0-19-850594-9. D'Arigel, O., The Mystery of the Einstein Euro Poincaré copyright connection, Assis 95, 614 Euro 626, doi, 10.1086/430652, PMIDA 16011297A. D'Arigel, O., The Genesis of the Theory of Relativity, ZA copyright Monnert Poincaré copyright 1, Euro 22, doi, 10.1007/3-7643-7436-51. Galison, P., Einstein's Clocks, Poincaré copyright S. Maps, Empires of Time, New York, W. W. Norton, ISBN A0-393-32604-7. Giannetto, E., The Rise of Special Relativity, Henri Poincaré copyright S. Works before Einstein, Atti dell'18 Congresso di Storia della Fisica e dell'Astronomia. 171 Euro 207. Guilledmin, J., Science and Convention, Essays on Henri Poincaré copyright S. Philosophy of Science and the Conventionalist Tradition, Oxford, Pergamon Press, ISBN A0-08-025790-9. Goldberg, S., Henri Poincaré copyright and Einstein's Theory of Relativity, American Journal of Physics 35, 934 Euro 944, Bibcode, 1967 MJPH 35934G, doi, 10.1119/1.1973643. Goldberg, S., Poincaré copyright S. Science and Einstein's Relativity, British Journal for the History of Science 5, 73 Euro 84, doi, 10.1017 per second 00070874000106333. Holton, G., Poincaré copyright and Relativity, Thematic Origins of Scientific Thought, Kepler to Einstein, Harvard University Press, ISBN A0-674-87747-0. Katsia, S., Poincaré copyright S. Relativistic Physics, Its Origins and Nature, Phys. Perspect. 7, 268 Euro 292, Bibcode, 2005 PHP, 7268K, doi, 10.1007 per second 00016-004-0234. Kiswani, G. H., Kilmister, C. W., Intimations of Relativity, Relativity before Einstein, Brit. J. Phil. Sci 34, 343 Euro 354, doi, 10.109334.4.343 Krang, H. Quantum Generations, A History of Physics in the 20th Century, Princeton University Press, ISBN A0-691-09552-3 Langevin, P. L. Angstrom Jules Henri Poincaré Copyright Le Physicien, Revue de Mar Copyright de Physique de Morale 21, 703 Macrossan, M.N., A Note on Relativity before Einstein, Brit. J. Phil. Sci 37, 232 Euro 234, doi, 10.109337.2.232 Miller, A.I., A Study of Henri Poincaré Copyright S sur la dynamique de l'électron, Arch. Hist. Exact. Sys 10, 207 Euro 328, doi, 10.1007/BF00412332 Miller, A.I., Albert Einstein's Special Theory of Relativity. Emergence and Early Interpretation, Reading, Edison Euro Wesley, ISBN A0-201-04679-2 Miller, A.I., Why did Poincaré Copyright not formulate special relativity in 1905? In Jean-Louis Greffe, Gerard Heinzmann, Cuno Lawrence, Henri Poincaré Science et Philosophie, Berlin, ppA 69 Euro 100 Schwartz, H.M., Poincaré Copyright S. Rendiconti Paper on Relativity. Part 1, American Journal of Physics 39, 1287 Euro 1294, Bibcode, 1971 MJPH 39.1287s, doi, 10.1119/1.1976641 Schwartz, H.M., Poincaré Copyright S. Rendiconti Paper on Relativity. Part 2, American Journal of Physics 40, 862 Euro 872, Bibcode, 1972 MJPH 4862s, doi, 10.1119/1.1986684 Schwartz, H.M., Poincaré Copyright S. Rendiconti Paper on Relativity. Part 3, American Journal of Physics 40, 1282 Euro 1287, Bibcode, 1972 MJPH 40.1282s, doi, 10.1119/1.1986815 Scribner, C. Henri Poincaré Copyright and the Principle of Relativity, American Journal of Physics 32, 672 Euro 678, Bibcode, 1964 MJPH 32672s, doi, 10.1119/1.1970936a. Walter, S., Henri Poincaré Copyright and the Theory of Relativity, in Rien, J., Albert Einstein, Chief Engineer of the Universe, 100 Authors for Einstein, 162 Euro 165 Walter, S., Breaking in the Four Vectors, The Four-Dimensional Movement in Gravitation, 1905 Euro 1910, in Rien, J., The Genesis of General Relativity 3, 193 Euro 252 Zaha, E., Poincaré Copyright S. Philosophy, From Conventionalism to Phenomenology, Chicago, Open Court Pipe Company, ISBN A0-8126-9435 Zan, Non-Mainstream, Kiswani, G.H. Origin and Concept of Relativity, Part 1, Brit. J. Phil. Sci 15, 286 Euro 306, doi, 10.109315. 60.286 Kiswani, G.H. Origin and Concept of Relativity, Part 2, Brit. J. Phil. Sci 16, 19 Euro 32, doi, 10.109316. 61.19 Kiswani, G.H. Origin and Concept of Relativity, Part 3, Brit. J. Phil. Sci 16, 273 Euro 294, doi, 10.109316. 64.273 Lee Vogel, J., La Relativity copyright A. Einstein, Planck, Hilberter Histoire copyright Riedic de l'Art copyright Henri de la Relativité copyright N. Pars, La Matana, Lganov, A.A., Henri Poincaré copyright and Relativity Theory, Moscow, Nauka, A.R. Ziv, Physics/04080777, Bibcode, 2004 Physics. 8077L, ISBN A5-02-033964-4. Whittaker, E.T., The Relativity Theory of Poincaré copyright and Lawrence, A History of the Theories of Ether and Electricity, The Modern Theories 1900–1926, London, Msona, external links, works by Henri Poincaré copyrighted Project Gutenberg, free audio download of Poincaré copyright Science and Hypothesis, from LibriVox. Internet Encyclopedia of Philosophy, Henri Poincaré copyright by Maura Muzzy. Internet Encyclopedia of Philosophy, Poincaré v. Unregistered Trademark S. Philosophy of Mathematics by Janet Folina. Henri Poincaré copyright at the Mathematics Genealogy Project, Henri Poincaré copyright on Information Philosopher, O'Connor, John J. Robertson, Edmund F., Henri Poincaré copyright, Makshita History of Mathematics Archive, University of St Andrews. A timeline of Poincaré copyright S. Life University of Lorraine. Bruce Medal Page, Collins, Graham P., Henri Poincaré copyright, His Conjecture, Copacabana and Higher Dimensions, Scientific American, June 9, 2004. BBC in Our Time, discussion of the Poincaré copyright conjecture, November 2, 2006, hosted by Melvin Bragg. Archive copy at the Wayback Machine, Poincaré contemplates Copernicus at Math Pages, High Anxiety ESA The Mathematics of Chaos BBC documentary directed by David Malone looking at the influence of Poincaré copyright S. discoveries on 20th century mathematics.